Although it is not that hard to solve a 2x2 after you've learned how to solve a 3x3, figuring out this puzzle on your own is actually quite difficult without guidance. And some of you out there that just learned how to solve a 3x3 may be looking to this puzzle and wondering how it actually works and can be solved, since there are no center pieces or edges. And this video is perfect for that because I will walk you guys through the beginner's method for the 2x2. Alright, step 1 to solving a 2x2 is actually just completing the white layer because there are no edges to solve the cross. And that's one reason why 2x2 is a lot faster than 3x3. It's because we don't have to worry about the edges. But here's the tricky part is we actually don't have the centers to guide us of where each color should go. So first, let's find an anchor piece. So literally just pick any corner with white on it and point it towards the bottom. So I'm going to use this orange, green, white as my anchor, right? And then to the right of this, I see like this should be orange. There should be orange here and then white down here. So now I look for another corner with white on it, but also has orange. So not this corner, this doesn't have orange. It does have white, however. This corner matches our description, has white, orange is here. And this corner again fails. So if the target corner is stuck in the bottom layer like this, we just take it out to the top layer with a sexy move, which goes R, U, R prime, U prime. So now it's on the top layer and we can work with it. And we know this corner has to go here. And it's the same principles as on 3x3. First, we move the corner over to the slot that it's supposed to go in. So not here, because that's our target, so we move it over. And from here, we just keep repeating the 4-move sequence like 3x3 to get this corner in. So the 4-move sequence, sexy move goes R, U, R prime, U prime. R, U, R prime, U prime. There. So now we have half a white layer. And now we continue the process. This should be blue here to match this, and we should have white on the bottom. So next we find a corner piece with white and blue on it. So again, this corner only has white on it, no blue, but this corner has white here and blue here. And we know it should go here, so this is our target corner, and this is where it should go. So first, we line it up to where it should go, just like in 3x3, and we start repeating the sexy move until it goes in. So it goes R, U, R prime, U prime. And it's done. And this will leave you either one corner on the top layer or one on the bottom. If it's on the bottom, you can just take it out with the R, U, R prime, U prime, the sexy move. But when there's one corner left, just line it up to the open slot because this corner has to go here now. And start doing the sexy move until it is solved. And there's our white layer. If you are familiar with 3x3 last layer beginner's method, you know that first we solve the yellow cross and then we'll permute around some yellow edges. But again, none of that applies here because 2x2s don't have edges. So we'll go straight to the corner permutating using the algorithm, the same one as on 3x3, and then finishing with the sexy moves. But in case if you have no idea what I just said, we're going to start from the very beginning with some basic recognition definitions. This corner here is what we call an OK corner for recognition. So an OK corner is a corner where the 3 colors on the corner belongs physically where it should be. So for example, green is where green is, orange is where orange is, and yellow is where yellow is. So this corner is physically in the correct spot. However, the corner does not have to be solved or orientated correctly like this one. This would also be considered an OK corner because red, green, yellow, this corner is also in between red, green, yellow. So in other words, if you can twist the corner where it is and it can be solved, then you know that's an OK corner. And again, this step, we're just trying to make 4 OK corners, and then we can finish with the sexy moves. So let's get into it. There are 4 cases, but technically the first case is a skip case, so I'm not going to consider that as a real case. This first case is quite straightforward. It's a skip case, which basically means you're done with the step and you don't have to do anything. So when you first run into this and you go like, you can't find any okay corners, just do some U moves around, see if you can find one. And when you do, you'll realize that in this case, all 4 are already okayed. So this is in the right spot because it's solved, solved. This is not solved, but it's orange, blue, yellow, and it's in between orange, blue, yellow, so that's also okay. And same concept here with blue, red, yellow, in between blue, red, yellow. So all 4 corners are okay, and you get to skip this step. Case 1 is one okay corner. So let's find that okay corner with red, blue, and yellow in between red, blue, and yellow. And none of the other 3 corners are okayed, as we can see here. And that is what we want. That is when you know we can execute the algorithm that we're going to learn right now. And this algorithm works only when this okay corner is at your front right corner, like this. And let's start the algorithm. The algorithm goes U, R, U prime, L prime, U, R prime, U prime, L. And depending on the case, you might have to do this algorithm either once or twice to get all the corners okayed. So in this case, we are done here because all these corners are okayed. Case 2 is adjacent corners being okayed. So first, this corner is okayed because orange, green, yellow, and it's in between orange, green, yellow. Its neighbor, it's also okayed with blue, orange, yellow in between blue, orange, yellow. However, this is not a skip case because the corners opposite of it are not okayed. In this case, we'll have to do one U move to create a situation where only one corner is okayed. And if you remember case 1, that is what we want to perform the algorithm with. So let's do a U here. This corner is not okayed with blue, red, and yellow in between blue, red, and yellow. And this is not okay, not okay, not okay. And that is what we want. So now we can hold this okayed corner at our front right and then just perform the algorithm, which goes U, R, U prime, L prime, U, R prime, U prime, L. And that is the case, and we can move on now since we are done. The third and final case is diagonal corners being okayed. So this is our okay corner. We got orange, blue, yellow in between orange, blue, and yellow. However, its neighbors are not okayed. Its other neighbors also not okayed. And we look across, and this happens to be okayed because red, green, yellow is in between red, green, yellow. So these 2 corners across from each other are okay. And when we run to this case, we just want to perform an algorithm, the algorithm that we did before, with an unokayed corner at our front right, like this. So this corner is not okayed, we keep it at our front right, and we perform the algorithm, which goes U, R, U prime, L prime, U, R prime, U prime, L. And after performing this, just do a few U moves to find another okayed one. So this is an okay corner, and then these 3 should all be not okay corners, because that's what we want. We only want one okay corner. And now we just perform the algorithm again with our okay corner at our front right. So now goes U, R, U prime, L prime, U, R prime, U prime, L. And if it's not all okayed because these 3 are not right, just do it again. And you should have them all okayed because you never have to do more than 2 times. And those are all the cases, and we can move on to the last step. With all the corners okayed, we can now flip the cube upside down and start repeating the sexy move until all these corners are solved. So this is exactly the same as the last step on 3x3 beginner's method. But I'm going to explain everything again in case if you don't know what I'm talking about. This bottom right corner is the solving corner, and that's the one we have to watch. So when this corner goes in with yellow on the bottom, then you know we have to move on to the next corner. So I'm going to start the sexy moves, which goes R, U, R prime, U prime, R, U, R prime, U prime. Don't worry about the top being messed up. It'll all be okay in the end. See how this corner is now in with yellow correctly orientated. So now we have to switch until another unsolved corner is at our solving corner, which is the bottom right. So let's just do that with a D prime. So now this unsolved corner can be solved with the same sequence of 4 moves: R, U, R prime, U prime, R, U, R prime, U prime. So now that corner is in as well, and we have to do another D move to find another unsolved corner and put it in our solving corner at the bottom right. So let's do another D prime and do the same sequence: R, U, R prime, U prime, R, U, R prime, U prime. And you should be only 1 move away or 0 moves away from solving the 2x2. And yeah, that's it. Pretty straightforward. I know for some new solvers that all this information seems equally overwhelming as learning how to solve a 3x3, but if you practice, you'll get faster in recognition and execution. However, if you want to get under 5 seconds, under 4 seconds for solving a 2x2, I suggest looking at some more advanced methods, starting with Ortega, and maybe even looking at EG. Just a warning, EG has over 120 algorithms in total, and I am just not that motivated to go that far for 2x2. I do know Ortega, and I average about mid 4, high 3 sometimes if I am lucky, but again, I'm not that interested in 2x2. So if you guys want me to make an Ortega video, I could definitely do that. Just leave it in the comments. But otherwise, if you want to look at some serious EG method stuff, then you can take a look at Perm's channel or some other YouTuber with more experience in 2x2 than me. So thanks for watching.